Alright, next up we have another finance problem. How much time would it take for an initial investment of $230 to quadruple if invested in an account that earns 13% interest compounding monthly? Monthly part means I'm using this formula here. A equals P times 1 plus the interest rate as a decimal over N raised to the T times N, where N is the number of times compounding per year. So monthly, that means that N equals 12. P is my initial amount. That's what I started off with. So P is going to equal 230. And quadruple, that means 4 times. So 4 times P, so 4 times 230, that should give me 920, I believe. Yep. So that will be my A in my formula. And I got to remember that when I write my interest, I need to move my decimal place. So if I have 13% interest, I have to move my decimal from where it is 2 places to the left. So that will be 0.13 for my R. Okay. So to clear it up, I have found most of my variables. A equals 920. P, my initial investment, is 230. R is 0.13. N equals 12 because it's monthly. And T is the unknown. That's what I'm solving for. So now I plug all this information into the formula where it goes and solve algebraically for T. So A is 920 equals P, which is 230, times 1 plus my interest rate, 0.13, over 12, raised to the 12 T. And I'm trying to solve for T there. Okay. In order to solve for T, I need to isolate everything away from it. So here we go. I need to divide away the 230. That will be 4 equals. I need to key punch and simplify this here inside the parentheses. So when I key punch that and simplify that inside the parentheses, we'll go ahead and do that in our calculator. So I have 1 plus 0.13 divided by 12. Can't use the N over key and the divide by. I'll do one or the other. That'll give me 1.010. And I'm going to keep a whole bunch of these decimals because it's not time to round yet. So I have 1.010833 repeating, raised to the 12t. Now I have a exponential, and the exponential, the exponent to the base to the exponent is isolated, so I can get rid of it using the inverses of exponents, which is logs. So if I go log 1.010833 and all that to the base of the same, they cancel. And that leaves me with 12t over here. What I do to one side, I must do to the other. So I'm going to go log base 1.010833 of 4. As I write this down over here, I'm going to use change of base. So this will be log of the argument, which is 4, over log of the base, 1.010833. equals 12t. Almost done. As I go to solve for t, 12 is multiplying times t, so to get rid of it, I'm going to divide it away. What I do to one side, I do to the other. So I'm going to divide this by 12 after I do all my log stuff. So let's key punch this, put it in the calculator. Big old parenthesis, log of 4. Over log of 1.0100833. Close the parenthesis and then divide by 12. And I get 10.721 years. So T equals 10.721 years. And last but not least, we'll write a nice little sentence saying we understand it. So the investment will quadruple in 10.721 years. There we go. I hope that helps. Thank you very much.